Know who I am, since all of you know who I am. So my name for the record here is Peter McKinnon, for those of you who don't know me. And I chair the FSN network on behalf of Jack Smith. And I might just give you an update for those of you who know Jack. He is still, in a state of rather poor health, but his spirits are high. And I know Martin can't speak up right now, but Martin and I do try and visit Jack from time to time at his home. So the thing I wanted to mention then is I'm also associated with the NextCon lab in the Faculty of Engineering, which deals with connected and autonomous vehicles. And it's one of the first university labs at the University of Ottawa to actually be moved off campus. It's now located in what's known as Kanata North, which is a high-tech park in the west end of Ottawa. And our lab actually has a test bed facility as well for autonomous vehicle simulations. And I also work in AI regards. I'm on the IEEE, the International Electrical and Electric Engineers USA Committee on Artificial Intelligence and Systems Policy. So that's a bit about my background. And now I'd like to turn to Derek. You've all had a chance to see his abstract and his brief bio. Derek is an assistant professor in human-centered design at Delft University of Technology in the Netherlands. And as stated in his resume, his consulting work or his research work is in design for well-being and in the design of AI systems to support well-being, and in the role of residents in interaction design. So as you know, he has a bachelor's degree in computer science from Yale, a master's in design from University of California, San Diego, and a PhD in human-computer interaction from Carnegie Mellon. So he certainly has a good background to be talking in this field. Over to you, Derek.
Hey, thank you very much. A small correction, the bachelor's degree is in cognitive science. And that was actually what introduced me to Plato, because I had, it was a degree where you had to have a mix of different fields. And I took a few philosophy courses, I love them. And then I took a course on philosophy of mind. And I was failing the course. I had some philosophical differences with the professor, who said that neuroscience had nothing to say and could never say anything, in fact, about philosophy of mind. And so I ended up dropping that course, but then I was stuck. I had one more course I needed for my degree. And I ended up getting a tutorial from this lady, Gabrielle Richardson, on pleasure, beauty, and happiness from Plato and Aristotle. And I'd never read any classics in that line before, and I don't know how I would have gotten into it otherwise. But that was when I fell in love with this idea of harmony, because I was at the time, there was this great lecture series on music cognition that was being put on at Yale. Then they'd have a lecture and they'd have some live music. And every single time it was pretty mind-blowing. And the idea that harmony was something that was such an obscure concept, because music theory is relatively obscure. It's difficult to understand what all the augmented sevenths and et cetera, are all about. And the notion of harmony is a concept that covers everything from inner peace to justice to, interpersonal relationships. What did that have to do with diminished sevenths, et cetera? So that was intriguing for me. I didn't have any idea what to do with those thoughts, but I was quite inspired by them. I also had no idea what to do with a cognitive science degree. And so I ended up working in New York City for Universal Music for a little bit of time, and then started doing some startup work, and then went to art school in San Diego. One of my engineering professors told me that it was free. You taught and they paid you to go to art school in Southern California. So that sounded great to me. And I still didn't really get to touch the concepts of harmony there either, though I had plenty of free time. It was only in the very end of my PhD at Carnegie Mellon when I was reviewing all these different theories of motivation, and I came across a really nice paper on Plato's theory of motivation, which had to do with the harmony of the different parts of the soul, which he roughly described as appetites, reason, and spirit. And it was a different conceptualization than some other tripartite models of motivation that I was familiar with. And so from there, I was able to dip my toes back in. And then during my postdoc, I was really able to, I started writing a book on it. And it was a very deep rabbit hole. And I'm really glad that I went down it, because I think I understand now why it's not a more popular topic of discussion in philosophy. And part of the reason is that it's difficult. I mean, it's difficult, and it's broad, and it's expansive, and a lot of things have been said on it, and it's difficult to get a handle on it. And another reason why it's unpopular is that it's uncool. It's been described as mom jeans 10 years ago. It just somehow doesn't fit with people. But I think it's coming back. I think it's something that it's such an important topic, and it's different from what people think it is. So with that, let me share my screen and let's see here. I'll jump into it. Mark, I was saying that I don't have a live violinist for this talk. So at some point I'm going to break into some Spotify, but we'll see. So this lecture I gave for the first time last Thursday at the Embassy of the Free Mind, which is the organization that hosts the Rittman Library of Hermetic Philosophy in downtown Amsterdam. It's one of the coolest places, just an incredible collection of books. The walls of the library are covered with these highly esoteric illustrations from all of these early modern publications that are all trying to communicate something about the ineffable, something about experience that just can't be put into words. And that's really the starting point for me on the topic of harmony, because there's a certain kind of wisdom that I think music can teach us that's very difficult to put into words. That's why we put it into music. If you could put it into words, why have music? But there's certain things you just can't. But from the knowledge that we get from music, there's implications for harmony in the rest of the universe, and that I think is very important to consider as we think about the design of the future, which is why I hope that this is relevant for this group. So Peter, thank you very much for the invitation. So one thing that harmony is not is uncontroversial. It is, or I should say, it's not controversial at all. Everybody wants to live in a more harmonious future. Everybody wants to have more inner harmony. It's in the preamble of the UN Sustainable Development Goals, harmony with nature. Who could disagree with that? Of course. But what does it mean? It's extremely unclear. But I believe as an assumption that understanding harmony, trying to really put some more effort into understanding it, would improve our ability to design for it. And part of the case I'd like to make is that we've been out of touch with the concept in sort of philosophical and psychological point of view for a pretty long time. It's played a large role in the past. Quite a lot has been advanced, but it's fallen out of favor, and it's really quite rare to be treated directly, with a few key exceptions. But the idea that we can understand it better, that would enable us to potentially create harmony with nature, or harmony in society, that's more controversial, because it's rare that a knowledge of harmony improves a musician's ability to create it. So this seems like a really clear-cut statement, but it's more of a hypothesis than anything else. Now, for myself, I run a research group called the AI and Experience Research Group at TU Delft. And one of the assumptions is that we want AI systems that are good for humanity. And the challenge is that AI systems, they optimize for numerical metrics. And how we turn humanistic values into numerical metrics is a very good question. We feel very uncomfortable about doing so. But this idea for me that we could potentially understand harmony better and use it to inform some of the metrics that we're developing was appealing to me, because harmony is surprisingly quantitative. It's surprisingly associated with numbers, even though that depends on the tradition, so to say. And I'll just mention that this is a piece that's come out from the lab. It's called Land Shapes, and it's a generative adversarial network that's based on satellite imagery. So all of these images they're of places that do not really exist. And it's this connection between the artificial and the natural that I think is rather beautiful. So I gave this lecture at this is the Embassy of the Free Mind, and it's filled with all these illustrations, like this alchemist laboratory. And topics like alchemy or esotericism are not terribly popular in the sciences. Certainly things like spirituality are not popular in the sciences. It's a pretty heavy taboo. It's interesting to see another taboo around psychedelic medicine, which up until a couple of years ago was about as taboo as you could get, suddenly make it into the mainstream and drag along with it the notion of mystical experiences as part of the medicine. And this is just really uncomfortable in many ways. And the conflict or cognitive dissonance between discredited forms of scientific inquiry like alchemy and modern society, I think represents some differences of interpretation about what these things are really about. And I just want to point out that right in the middle of this alchemist laboratory, you'll see those musical instruments. And that's surprising and takes some more explanation, but that helps explain why I was giving this at the Rittman Library of Hermetic Philosophy. Also, the images are a way of communicating things that are difficult to put into words, like what this fellow is experiencing here. Somehow this image communicates this notion, I think, better than however someone would try to put that into words. So when I started to write this book and jump into a more rigorous approach to what harmony really is, of course, I Googled it. And the first thing to come up when I looked at harmony as a principal design is that harmony can be described as sameness. And I don't know about you, but that's a horrible principle. I mean, the idea that we want a more harmonious world, and by that we want things to be more the same. All of a sudden it starts taking on a little bit more of a nefarious vibe to it. I mean, maybe harmony is not really what we want in the world if what it's really about is uniformity. And so what's interesting is that this is such an old misconception that back in around 500 BC, Confucius is addressing it explicitly. So he says, the good person harmonizes but does not seek sameness, whereas the petty person seeks sameness but does not harmonize. And this is a very different viewpoint than the idea that harmony is just about uniformity and sameness. And so as a rough definition, I would suggest that harmony is the integration of diverse elements into a whole. So that's a working definition for this lecture. And I'll point out that yin yang symbol because that's a symbol of harmony, that you can have these two opposing, conflicting elements brought together into a whole. So the paper that this is based on is long. And part of the reason that it's long is that it covers a lot of ground. It's from classical philosophy and the Eastern and Western tradition, as well as pointing to non-Eastern and Western traditions, such as Native American philosophies and indigenous African philosophies, which also have a strong conception of harmony. And then from there into the Renaissance and the early modern period, psychology, neuroscience, economics, and design. So quite a lot of material, but the paper is worth checking out, even if you don't read it, because it's really designed to be skimmed. There's some nice illustrations in it, like this fish rice system that's used in China, where the rice grows, it attracts insects, the fish eat the insects, the fish poop fertilizes the rice. And this is a whole system and a great example of harmony in sustainability design. But underneath this, you can see this use of reflective propositions. So out of all of the material that's reviewed, I put these enumerated propositions. And so that means that you can go through and just read the summaries in these statements and get a sense for what might be interesting to go back to. Now, by the end of the paper, there's exactly 100 of them. So just the propositions themselves are still takes a few minutes to go through, but I hope that you'd find the paper interesting. It makes it much easier to give this talk because I don't have to reference everything with great clarity. It's all in the paper. There is another paper that's just coming out now about resonance. Harmony and resonance and vibes are all part of a kind of complex. If you see a film that resonates with you, or you meet a new friend and there's a kind of resonance, this is a very common part of conversation and culture, and we do a very intensive review of the concept in interpersonal empathy and motor resonance, because there's actually quite a lot of measurable resonant phenomena in the brain that's observable and can be described. Just the basic idea that if you've got two tuning forks that are attuned to the same frequency and you strike one and there's some intervening medium, the other one will start to resonate. Or the same with a plucked string. You can get a plucked string to get another plucked string to vibrate even though you didn't touch it. And we then apply that to social robots. So again, just to give some definitions here, that sympathetic resonance involves the, just trying to move the, see, excuse me, I need to drop the video. Okay, so sympathetic resonance is of aligned frequencies. So when frequencies are aligned, then the systems will synchronize and amplify one another. And harmony, that this is the integration of diverse frequencies into a whole. And so for thousands of years, philosophers have been inspired by music and have used musical references as a model for the mind and the broader cosmos. And so, for instance, Plato here describes, he says, harmony has motions akin to the revolutions of our soul. And that's very nice, because if I take revolutions like oscillations and soul like psyche, yeah, that's really true. There are lots of rhythmic oscillations that are pervasive, you know, heartbeats and breath and sleep cycles, and our brains are made from billions of oscillating neurons. And this notion that we're vibratory beings, that sounds very esoteric, spiritual, but it's very, very true. And it's interesting that the first person to introduce this idea was Isaac Newton. In the very last paragraph of his Principia Mathematica, he suggests that the operation of the mind and mental activity was through vibrations in the neurons. And this idea was rejected immediately by the medical community, because they pointed out that neurons are much too flaccid to communicate vibrations. So the notion of electrical vibrations was completely alien, but that was originally introduced by Isaac Newton. We know now that there are lots of different, so neurons are oscillators, but even very simple circuits, they produce these reverberations and resonances. We've got rhythmic pattern generators all throughout our spinal cord, and it's essential for many, many different aspects of cognition. This is a nice representation of electrical waves moving through the brain that was produced by the Human Brain Project. So this illustration probably cost a few $1 billion here. So it's also something that's very common in culture. So we say, let's sync up, or there was a good vibe, or we resonated with each other. I wanted to share this video because it takes a surprisingly short amount of time for tuned metronomes to all start synchronizing with each other. So their phases are all out of sync right now. But you can notice the shaking on the table that they're sitting on, set up with these mathematically calibrated cans of beer, cola. And in just about the amount of time that it took me to make that beer joke, the metronomes all started synchronizing with each other. And that's because this is a lower energy state. And this phenomena, this mathematical phenomena of synchronization, is totally pervasive in the brain and all of its powered oscillators. And it's like magic. And this is right at the heart of the conceptualization of magic, which is another concept that's very uncomfortable in the sciences, of course. But listen to this. So this is Plotinus, who's really a wonderful Neoplatonic philosopher from Alexandria. He says, but how do magic spells work? By sympathy, and by the fact that there's a natural concord of things that are alike and opposition of things that are different. It is the irrational soul, not the power of choice or the reason, which is charmed by music. And this kind of magic causes no surprise. People even like being enchanted by music. And I like this idea because it takes whatever our conceptions of magic are, Harry Potter and all the rest, and recognizing music as a type of magic, I think is really appropriate. because one way that I, rather than defining magic as just anything that doesn't exist, treating it as something that has power that we can't quite explain, where you can intentionally produce an effect through a mechanism that you just don't understand. And I think music certainly falls into that category. Other things like architectural decorations or other aspects of design, I think, also have that aspect. Now, probably because of the association with magic, it took a long time for resonance to be accepted by the scientific community. There was a recent article in Nature Physics that described that resonance, when it was used in the sciences, was only by analogy. And so even something like mechanical resonance was only by analogy to acoustic resonance, which was recognized. But then once we recognized that resonance was pervasive as a physical phenomena, it was incredibly powerful. Now we have international global telecommunications, which is all based on electromagnetic resonance. And there are many other technologies. It's one of the most successful scientific theories or phenomena of all time, I'd argue. Now, the notion of magic in design, I think, is valuable because there's a reason why it's design and not engineering. There are aspects of human behavior that we just shouldn't even claim to understand. We might, drum up some psychology study to, indicate why something happens. But at the end of the day, there's a lot of intuition at play. And something like, it's common to think that just by having the idea in your head, just to have the kind of positive vision of something happening, you might be able to bring it about through some law of attraction or something like that. This is a type of magical thinking. And well, that's pretty easy to critique. On the other hand, the ability to take something from our mind and turn it into reality, I think is absolutely magical. And I think it's something that can help us respect and have a little humility even towards creating realities that we want to have happen. And so I think about this, we can just be rational about the value of irrational thinking. The use of intuition, the use of optimistic, magical thinking can itself be a very rational thing to employ, if you're running a startup or otherwise. And this integration of inspiration and rationality, I think, is important because we can become so enamored by the rational that I think we forget about the other aspects of our cognition. And it's not that these things need to be in opposition to each other. It's not that when we draw inspiration, we should turn off the rational side of our mind and believe things that don't make any sense. But for instance, this is the alignment of the stars, of the planets right now. It's a pretty inspiring celestial alignment. Now, hundreds of years ago, we might have believed that this would have additional powers that were affecting us. And maybe we'd try to come up with some argument of how the planets could affect us. But the gravity exerted by your computer is probably greater than the gravitational forces of those distant planets. But you can still be inspired by a celestial alignment. And I think that that's something that we should really leave room for in society. So to just bring this section to a close, the major idea here is that music has a sort of philosophical wisdom that's very difficult to put into words, and probably some aspects of it are just impossible to put into words. And the principles of music can help us explore some of the deeper principles of the universe. Musical harmony is not just chords. It's not just simultaneous notes. A definition I'd give is that it's how different notes and rhythms and all the different parts of music fit together to make whole units and compositions. So harmony is something that unfolds over time as well. I think that that's important. And harmony in general is how diverse elements are integrated together to make wholes. The notion of diversity and unity is a notion that is also a good definition of harmony, also a good definition of beauty. So the question of why it is that certain numerical proportions make for beautiful sounds is, I would argue, the very first question that was posed scientifically in history. And I'm going to go into this a little more. Is there a question there? No. Okay, so this was where I'd break into some lovely violin music, and Juliet played a piece, La Folia, and its translation for La Folia could be the madness, and it's a piece that has a lot of dissonance in it, and is totally crazy. It's a really crazy piece. But instead of doing that, what I'd like to do instead is maybe I'll contrast two different pieces here. So I've got something that I can bring up. This is Zarlino, who I like very much. But this is a sacred music, sort of church music. And I just wanted to play a little bit because it's extremely harmonious. And I'm going to just contrast that. What do you do? Okay, you can uncover your ears now. I wanted to contrast these two pieces. So first of all, hopefully you saw some of the lyrics for Niagara Sum said Formosa, I am black and beautiful. This is a piece that is, it's a lovely piece. It's also a kind of tragic piece, but it's beautiful. But there's that tension of that you can hear in it. It's not the happiest piece in the world, but it is extremely harmonious in its construction from one sense of the word. Now, one of the deeper wisdoms that Frank Zappa reveals is that we can't just say that Broken Hearts Are for Assholes on his Shake Your Booty album is just horrible music. Now, you can absolutely have that opinion, and many people do, but it's something where the tolerance that we can have for music can enable us to appreciate much more than if we are too close-minded about things. And we all know that there's incredible music that we've come to love, that maybe at first we were skeptical of, or in any case, there's incredible music that we love that we just don't understand why other people that are close to us don't love it. And we wish they had just a little bit more tolerance for the thing, because we find it quite awesome or gorgeous or beautiful. Now, this notion that there are many different types of harmony, and it's not just what seems to be harmonious, is, I think, an important wisdom. But at the same time, we can recognize that some sounds sound better together than others. Now, I want to give a demonstration of this. So let me share my screen again. And I've got, oh, not here. I want to, nope, that's not what I want to show. I want to go to Audacity. Okay, and you can see my screen here. Okay, so this is just a single monochord string playing. Okay, now I'm going to copy this, and I'm going to make a new track and paste that in. And I'm going to change the pitch. And starts off, the first one you heard was 380 Hertz. So I'm going to change it to 440 Hertz, because that's an A. That's something we might be familiar with. And now I'm going to play them together. Now that's a little bit rough. Now that's essentially a random combination of sounds. So if I take this again and I make another track and I paste this, and then I put it at an octave ratio, and so I'll change it to, so I've got one there that's 440. I'll make this 220, and I'm going to mute this one. Now those, maybe you can't even tell the difference there, but let me mute this one too so you can. Those fit very nicely. Now this notion of fitting nicely is something that was explored. Let me give one more example here. So if I've got this as the doubling of frequency, what I can do is make another track, and I'm going to make this one. So now we start at 220, and I'm going to increase this by, or actually, you know what I'll do is I'll take this one here, take this one here, and I will change this from 440, and I'm going to put it a fifth below. So I'm going to change this, or a fifth above. Sure. So 66% above. Now I'm going to mute this one. We'll just play these. Let's see. So two. Now, maybe that sounds a bit clanging because it's getting higher. So let me unmute this one, and then we'll. That's really difficult. Okay. So maybe you have that same experience as me. Maybe you don't. We'll never know. But it was enough of a commonality that it became accepted that there was a difference between consonants and different dissonants. And the numerical proportions in consonants are something that is worth explaining. So in an octave on a piano, the do, re, mi, fa, sol, la, ti, do, those 8 notes, 1, 2, 3, 4, 5, 6, 7, 8, this is an octave. Or a fifth, where you start in the same note and you say 1, 2, 3, 4, 5. This is a fifth. And on a violin, the octave is exactly 1/2 the length of the string. So if you want to take any of these strings and play an octave higher, you just press 1/2 the distance and bow away, and I'm sure you'll produce beautiful music because novices are great at playing violin without practice. Now, if you want to play a fifth higher, which is another nice consonance, then you push 2/3 of the way up the string. And this is how a violin is tuned. If you play each string while pushing the one next to it at 2/3 the way, then they'll make the same sound. And so that's the tuning of a violin. Now, Pythagorean harmony, not Pythagorean tuning, but Pythagorean harmony is based on these small integer ratios. So this representation here, where the open string is a do, then you can see re is an 8 to 9. Now, a re is a second. So if you push two notes together on the piano, they don't sound so nice, and those are high integer ratios, so they don't sound as nice. Now, the low integer ratios, like do, again, the octave above, has a ratio of 1 to 2 because it's half the length. So this length times 2 is the whole. Or so, the fifth is a ratio of 2 to 3. A third is a 4 to 5. Or a fourth is 3/4 of the way. Now, this is not equal temperament. There's a lot of other things to say about this. But this idea that small integer ratios produce beautiful sounds was the first scientific hypothesis. It was the first mathematical model of a phenomena, and the phenomena being, why does this sound nice, that was empirically tested. And so let me just give another explanation of this and then pause for clarity if anyone has some clarifying questions. But so you can see that if you push halfway along the length of this string, let's say this original string was producing 100 hertz, then if you push halfway in the middle, that's 200 hertz. If you push 1/3 of the way, it will produce 300 hertz. So you can see here, this is the fundamental, the open string. If we make that 100 hertz, then halfway, that's double in frequency. If you were to push here and pluck here, I'm not sure if you can see my cursor, but if you were to on this the 300 hertz here, yeah. So and the experiment was that the Pythagoreans, they noticed this relationship between small integer ratios and strings, and they tested it in bronze chimes. And this is attested by Aristotle's student Aristoxenes. So it's on a pretty good source. Plato also made reference to this. And so this first scientific experiment, testing a mathematical model with empirical evidence, because of course, when they tested these bronze chimes, indeed, they produced an octave and a fifth. Are there any questions on this?
I don't see any hands
Okay.
or anything in the chat at the moment.
I find it very difficult to understand music theory, and I feel that many people don't know much about it. So I try to make that as clear cut as possible, but there aren't stupid questions about it because it's obscure stuff. So
there is a question now, or a comment from Sydney Wu, and Sydney's out in Calgary. Hasn't had a chance to speak up yet because he came in a little late. So maybe go ahead, Sydney, and you might just say a couple of words about yourself.
Okay, well, I don't know how to start talking about myself, but I have been talking to Peter McKinnon, and he introduced me to this link and this talk, and I find it very interesting. And about this harmony thing, I just want to point out, I'm not an expert, I'm not a musician. I just point out that Bach has composed a series of music called 48 fugues and variations. And it is called the well-tempered clavier.
Mhm.
The well-tempered clavier is that all the octaves he tempers, and not exactly per mathematical orders, and he tempered it. And if it is according to the exact harmonic orders, then it sounds harsh. But if he tempered it, tune it a little off, then it all sounds nice to the ear. And he
Yeah.
proved the point by composing the 48 pieces.
Yeah, it's a great point, and it's something that is I think a general point to make about harmony, which is that it can seem so simple like this. It's small integer ratios is the basis of it, and it's a slippery concept. It's actually more complicated than that. So even though while and I'm not sure how they do well tempering. I know that's a little bit different from equal temperament, which is based on the 12th root of 2. So there's still a kind of mathematical proportioning going on. But indeed, the problem with just temperament or Pythagorean temperament is that you can't transpose music. And you're limited to, basically 2 octaves that you can work with. And so Bach's demonstration that you could make all these new kinds of harmonies when you adjusted the ratios. So they were no longer these clean numeric proportions, but were in fact no longer rational. So they no longer had rational numbers as their basis, but they were close. And so by putting them just a little bit off, they were closer than when you transpose them between different octaves. And I can just point out something which is, I go into much more detail in the paper, but you can see here that while there's a single tone of this 500 hertz or 440 hertz tone here, you can see all the harmonics. So you see, this is the fundamental frequency down here, 440. I guess that would be up here. Oh, this is the 221. So must be this one right here. So now the harmonics are roughly doublings of frequency, but any instrument has its own timbre of harmonics. And what's interesting is that consonant notes tend to have alignments in their harmonics. And one of the more contemporary theories for why notes sound nice together is because their harmonics align. And the belief is that this produces a kind of resonance in the neural oscillators that are representing those notes. And so you need fewer neural oscillators to represent the notes. It's kind of easier for the brain to process those multiple notes as a whole. But that's going a little bit into the weeds. But just suffice to say that it's a very good point that the Pythagorean harmony is close, but it's not an adequate or complete representation of what harmony is. So the key idea here, though, is that somehow with harmony, we're able to integrate diverse elements into wholes. And one thing that happens, say, with an octave, so this is a representation of an octave, because so this is a wave that is twice the wavelength of this one at the top. And you can see that every other peak, it kisses with the other one. And so this notion that it's well integrated. For instance, if you have an irrational interval like the golden ratio, it doesn't sound very nice musically. And one of the theories for that is that these peaks never coincide. one of the great arguments between just temperament and equal temperament was between Zarlino, who I just played, and his student Vincenzo Galileo, who was the father of Galileo. And both father and son, they conducted musical experiments in their basement and helped work out the equations relating the mass of a string to its tension, its length, and its pitch. And so now, so this is a discussion of the mathematics of consonance and dissonance. But then from Plato, we learned that there's a harmony in the soul, and then that's virtue, and that health is harmony in the body, and justice is harmony in the state. And it's a bit obscure. How did we jump from harmony in music to harmony in these other areas of existence? And so this is Raphael's School of Athens. You've got Plato on the left here, and he founded the academy that I'm still a part of. So good job, Plato. And Aristotle, who was tutor of Alexander the Great. And so this progression of intellectual ideas obviously had a huge impact on the world. And down here is Pythagoras, who predated Plato, but was one of his biggest influences, perhaps even as a bigger influence than Socrates. And this is a timeline that shows that Pythagoras was contemporary with Gautama Buddha, Lao Tzu, Confucius. Of course, they didn't know each other. They were on different sides of the world, but the fact that such incredible philosophical ideas were changing society by these people that were all contemporary to one another, I just think is amazing. But you can see the distance in time between Pythagoras, his students here, and Plato. So these were all Pythagoreans. It was probably Hippasus who conducted this first scientific experiment of all time. Now, the legend of Pythagoras, I think, is amazing. So he grew up on Samos, the island of Samos, during the reconstruction of the largest temple in the world. And what's interesting is that this largest temple in the world was dedicated to a woman, to Hera. And there was quite a strong influence of women in Pythagoras's life. Now, he grew up on this island of Samos. His father was from Tyre, so he was a Syrian. So Pythagoras was a kind of multi-ethnic individual. There's a story also that he competed in the Olympics when he was 16 years old. And the records of the Olympics are pretty well kept. And so the story, which is recounted by Eusebius, is that he went to compete in the boys' Olympics, and he was made fun of for his long hair and effeminate nature, and was kicked out of the boys' Olympics. But he managed to join the men's Olympics in boxing and won because of the demonstration of his technique. Now, then Pythagoras, probably through his father's trading networks in Tyre, he traveled a lot. And the story goes that he tried to assemble all of the different philosophies of all these different cultures that he had exposure to. So he was very deliberate in assembling a diverse perspective of as many different cultures as he could get his hands on, essentially. There's some good evidence that he was given an introduction to be made an Egyptian priest at Hermopolis as well. And so he traveled a lot. He initiated himself into as many different traditions as he could. He was deeply influenced by the Oracle of Delphi, which probably directed him to go found a school in Croton in southern Italy. And At the time, there were a number of different perspectives on the nature of things. And so while Pythagoras was the first to call himself a philosopher or a lover of wisdom, one of his predecessors was Thales. And he believed that everything was made of this kind of fluid, flowing substance. And so the notion that the arche, the sort of first principle of everything, was water, is Thales' idea. Now, his student, Anaximenes, believed that everything was made of air, that if you got right down to it, it was a kind of airy substance to everything. And for Pythagoras, everything is made of math. And this is a pretty awesome perspective, because on one hand, that seems ridiculous in a sense, that material things are made of math. And yet this is about as close to the contemporary physical perspective of the world as you can get. This is modern physical ontology, that the world is somehow in a basic way constructed of mathematics. And so this is a nice illustration of him. Now, Pythagoras wrote no books that have survived. And he may have written no books at all. In the sort of legends around him, because Pythagoras is one of the best known Greek philosophers, at least because of his theorem, the Pythagorean theorem. But there's little else that's known about him in popular culture. One of my life objectives is to get another page devoted to the fellow in math textbooks, because I think that people would really benefit from it. But the core idea is recounted here. So the principle of all things is the oneness. From the oneness and the two-ness arise numbers. From numbers, points. From points, lines. From lines, shapes. From shapes, solid figures. From solid figures, sensible bodies. The elements which are four: fire, water, air, and earth. These elements interchange and turn into one another completely and combine to produce a universe, animate, intelligent, and spherical. Now, this is from Alexander Polyhistor, who's synthesizing the works of the Pythagoreans. But the idea was that the universe comes from this oneness. Well, that's modern physics. We call it the singularity. And the notion that the atomic elements are based on the most basic geometries. Well, of course, it's not fire, air, earth, and water, although plasma, solids, gases, and liquids are the four states of matter. The notion that basic geometry would produce physical, the physical properties of materials is still a physical concept, except the simplest geometries are not Euclidean geometries, but rather these spherical harmonics that you get in electron orbitals. And so these ideas are very ancient, and they have a pretty incredible staying power. And that's part of what I want to point out. Now, the other thing that I think is just incredible, because I'd like to make the case that one of the reasons to include more Pythagoreanism in the math textbooks is that they wouldn't be accepted by Ron DeSantis. Now, okay, we can have different opinions about this, but the recognition of diversity and inclusion as a principle of harmony, and that recognizing women and diverse perspectives is at the core of Western civilization, I think would be surprising to many people. And I think it's important to know, because let's face it, the classics are not doing so well in academia these days. But Pythagoras not only integrated all these diverse cultural perspectives into his philosophy, but he also credited a woman for the majority of his doctrines. And that also comes from Aristophanes, Aristotle's student. Now, this is Themistoclea. Themistoclea was the oracle of Delphi, the Pythian priestess. And she was probably the most influential person in the world, because everyone would come to the Oracle of Delphi for advice. And here she is with these three different forms of divination, listening to the rustling of the laurel leaves, observing the ripples of water on this dish, and feeling the vibrations in this bronze tripod. And who knows what else she was smoking, but the Oracle of Delphi was incredibly influential, and he credited her for his philosophies. He also cultivated female philosophers that were named and had works that were propagated through history, and that's Theano and Maya. And his society was open to women. It was a sort of secret society in a sense, or it was after they were massacred twice by their opponents. They became more of a secret society. But the school that he established in Croton had two different types of members. There were the acousmata, which were the listeners, and anyone was welcome. And then there were the mathematicoi, that were essentially the grad students. So they had to take a 5-year vow of silence. And then the mathematicoi, they became the kind of inner circle of the Pythagoreans. They also held all their possessions in common. So they were the first attested communist society as well, which is very interesting. Now, again, I'd just like to make this point about harmony as unity and variety, and diversity and inclusion. I think this is important. And I think it's important to recognize that some of these contemporary concerns are rather ancient concerns as well, and that there are stories that deserve to be told to school children from the classics. Here's a nice critique of these Pythagorizing women. If they happen to meet a foreigner, they will happily hold a cross-examination of their doctrines to trouble and confound him with terms, equations, and antitheses, brain-bunged with magnitudes and paraphrases. Okay, well, Cratinus didn't like nerds, I suppose, but I do. And I think it's great that you have this kind of critique of the Pythagorizing women in antiquity. Now, one of the symbols of Pythagoras, of course, is the triangle from the Pythagorean theorem, but another symbol is the tetractys, also a triangle. And this is a mystical or magical symbol that emerges from these notes. So that where you can press on the string, where you divide up the string to produce these different harmonies. And here's just another representation of it, that you've got this open string, and then you have the tetractys formed here. The tetractys is this representation that all is number. That was how Aristotle summed up the Pythagorean philosophy from Diogenes Laertius, that all things are constructed according to the laws of harmony. And what was observed in the tetractys is that harmony exists even in arithmetic, even in numbers. There are these repeating units that produce wholes. And this is represented by the fact that 1 + 2 + 3 + 4 = 10, this wonderful number that we can see on our fingertips. And so that you have harmony even in numbers themselves. And harmony in numbers in space is geometry, that we can produce these wholes out of parts that are not arbitrary. There's only a certain number of basic 2-dimensional or 3-dimensional shapes, and that there's a kind of beauty to them, to these wholes, the production of these wholes. And that you also can produce these wholes in numbers in time, which is music. and then harmony in numbers in space and time as cosmology, the music of the spheres, the harmony of the spheres. And so this quadrivium was part of the Renaissance instructional system of the 7 liberal arts. You had the quadrivium and the trivium together. And this is, these 4 are often not taught in the liberal arts today, but I think that it'd be valuable to do so. It's worth mentioning, at least as an aside, that brain waves have an octave relationship to one another. So when you have an alpha wave, the octave up or double the frequency is beta, and double that is gamma. You have these sort of subharmonics of alpha in theta and delta. And that harmonics and harmony is in a way part of the structure of the brain. And as we'll see with Kepler, it's also part of the structure of the stars as well. This is one last piece that I think is nice to share from the paper, which is how little parts can become wholes. So you see how in phonemes, the different frequencies come together into syllables, and from syllables into words, and from words into phrases, and phrases into sentences, and sentences into stories. And it's all about this hierarchical creation of wholeness that can be assembled together. And that's really what's so amazing about humans, is that we can do this. We can create these wholes over time. This is perhaps one of the only things that Pythagoras wrote. So Ion of Chios said that he wrote some Orphic hymns. So he just attributed these to Orpheus, but supposedly Pythagoras wrote some hymns. And this, I think, is probably by Pythagoras. That's, of course, irresponsible to say, which is why I like to say it. So you hold the boundaries of the whole universe. You care for the beginning of the end so that everything can flourish. The resonance of your guitar attunes the whole sphere. And this was translated by Marsilio Ficino, who I'll be mentioning here in a few. Now, one thing to take from this is Apollo's guitar is an allegory. No matter how literal we take the harmony of the spheres, no one's imagining that there's actually a giant guitar in the sky. But the notion of the allegory and how seriously we take the concept of harmony is at stake. It's something that can be discussed. So this is another symbol of harmony, the Vitruvian Man by Da Vinci, who in his On Painting said, "Do you not know that our soul is composed of harmony?" Now, he was writing just after, he would have read these classic works of Plotinus and Plato just after Marsilio Ficino translated them in Florence. And this is a symbol of harmony. Vitruvius writes, "In a temple, there ought to be harmony in the symmetrical relations of the different parts to the whole. In the human body, the central part is the navel. If a man is placed flat on his back with his hands and feet extended, etc., etc." So this is showing the harmony of the human body in analogy to the harmony of the symmetrical relations in a temple. So harmony isn't just in music in classical terms. It's something that's extended to the human body, it's extended to architecture, it's extended to health, it's extended to the design of the state, and it's extended to the cosmos, the understanding of the cosmos. So here you've got Da Vinci up here, and shortly, contemporary with him, you have Copernicus, and then down here is Johannes Kepler. So that's who I want to get to be talking about here. He helped kick off the scientific revolution. He put his 3 laws of gravitation in a book called The Harmony of the World, or Harmonices Mundi. And this is upstairs at the Rittman Library. You can see Robert Flood's cosmic monochord next to Kepler's representation of the crystal spheres that were holding the planets on this superstructure of the basic Platonic shapes, these three-dimensional shapes. Now, Robert Flood used this cosmic monochord as an allegory to talk about the divine harmonies that connected the microcosm to the macrocosm. And Kepler disagreed. He thought, you're just treating this like an analogy, but there are really harmonies in the cosmos. This isn't just an allegory. This is something that we can observe. And that was his life's work, to observe the harmonies in the cosmos. Now, this is the Ptolemaic representation of the movement of the planets. It's rather beautiful. It also fits the data very well. The problem is that it's Earth-centric, and it's difficult. This was something that came out recently by NASA. It's a representation of the known universe. They didn't make the mistake of putting the Earth at the center, but of course the Earth is at the center of the observable universe. There's no way around this, or at least whatever. It will be center to whatever satellites we can send out, or probes we can send out. It will center from the Earth. The universe doesn't revolve around the sun or the Earth, but certainly our perception of it does. Now, for Kepler, he wanted to have a heliocentric universe. And the reason for this was not because it fit the data better. In fact, it didn't fit the data very well. He wanted to bring it back to a sun-centered universe because it was Pythagorean, and Copernicus loved Pythagoras. He loved the Pythagorean tradition. And the Pythagorean tradition held that the planets were traversed around the sun in these crystal spheres, and the speed of the planets produced a sound, and the different speeds produce these sounds in the planets, and together they created the harmony of the spheres. And here's this nice reference from Copernicus to Hermes Trismegistus, who is the Egyptian Thoth, or Hermes, and wrote a number of different works that are very difficult to understand. And this is the basis of Hermetic philosophy. There's a lot to discuss there. It's complicated, is all I can say. So Kepler believed that like the basic geometries produced the basic atomic elements, that the basic geometries should also produce the movement of the visible planets. And he saw the basic geometries as providing the superstructure for these crystal spheres. And it's quite amazing that the data fit pretty well. It fit better than Copernicus had it, but not that well. And he thought the problem was with the measurement instruments. And so he devoted quite a bit of time to getting better data from Tycho Brahe, a Danish astronomer who was collecting and amassing a really incredible data set on the movement of the planets. Now, the point I'm trying to make here is that Kepler was really operating on a kind of faith that we live in a harmonious world. And that's irrational for a number of different reasons. Not least of which, he was right in the middle of the 30 Years' War. And the idea that we live in this harmonious world, that we can see the harmony of the spheres and that it's harmony all the way up, is quite irrational. This is a illustration, a representation of his mother, Katarina Kepler, who was accused and tried and convicted of witchcraft eventually released from prison after 14 months and died a year later. But this notion that he lives in a harmonious world, even as his mother is being accused of witchcraft, is quite irrational. It certainly didn't fit what was around him. Now, Kepler was partially to blame for his mother's accusations, because he wrote a science fiction novel to break people out of their geocentrism. He wanted to point out that, well, here's what happened. He wanted to point out that when travelers would go to the moon, they would see the Earth moving around them as though the moon were fixed. So from the perspective of being on the moon, the Earth was rotating around it. And so to set up this science fiction story of the travelers going to the moon, he had an herb doctor summon demons to take the travelers to the moon. And his mother was an herb doctor. And so the notion that she was capable of summoning these demons that could take people to the moon must have weighed on Kepler. But throughout all of this, he was so devoted to this notion that harmonies were actually manifest in the cosmos, that even when he had to come to terms with the inability of the crystal spheres supported by these basic Platonic forms, when he realized that this did not fit the data, rather than deciding that no, the universe is not harmonious after all, he changed his conception of what harmony was. And that enabled him, I think, to have the devotion to the data, to find within it his three gravitational laws. And it enabled him to publish this musical notation of the numerical proportions, the harmonic numerical proportions of the planets. So what this is showing is that in the proportions of, so the fastest the planets are going is when they're closest to the sun. So he had to discover that the planets don't move on crystal spheres at all, because they don't move in circles, they move in ellipses, and that they don't move at the same speed. When they're closest to the sun, they move faster than when they're furthest from the sun. But what he found was that there's a harmonic musical proportion in the speeds of the planets when they're closest to the sun and furthest from the sun. And this is what he published here. Now, you could say, well, so what? I mean, what does it really matter that that the planets have these musical proportions? That's not really helping us with anything. But it was his motivation for discovering the three laws of gravitation and kicking off the scientific revolution. So I think we want to somehow make sense of that and credit his devotion to this concept of harmony, and also to his willingness to change his conception of harmony so that he could respect the data. And I think that that's something that allows us to integrate whatever inspiration we can draw from the notion of harmony to a scientific rational worldview. It's just being willing to change what we think harmony really is so that we can fit the data. Because this notion that we live in a harmonious world is again, at least a 2,500-year-old idea, and it has incredible legs. So the cosmic microwave background radiation is the variations in the oneness, as it were. So when the singularity inflated into the Big Bang, there was a period of where all matter was plasma. And during this time, as soon as matter was formed, acoustic waves were moving through matter. And so the whole universe was ringing like a bell. And until the universe cooled enough for the electrons to associate with the protons and the plasma period to end, that's when the ringing stopped. This distance of the ringing is something that provides a standard astronomical distance across all parts of the observable universe. And that's what's shown in this top left image, because what would happen is that the acoustic compression, so acoustic waves are just compression of matter and expansion of matter in an oscillation, and those compressions resulted in a greater gravitational force, and it would produce these clusters that had a large amount of matter and especially dark matter, and then the ringing would extend out from it. And so the distance between the center and this ring is all the same all throughout the universe, because things cooled down at roughly the same amount of time. And out of this graph on the right is the result of billions of dollars of investment in satellite imagery to be able to scan the whole sky and measure this cosmic microwave background radiation, where there was the discovery of harmonics in the cosmic microwave background radiation. And so this notion that we live in a harmonious universe, at least from a physical perspective, it's astonishingly accurate. So having a perspective that one will find harmonies in the cosmos or in the brain or in any kind of complex system can be a guide. It can be a place to stake new hypotheses and then see what the data say. So the last story that I wanted to share is about Marsilio Ficino, because the Renaissance was an important event in Western history, and it really happened due to the fall of Rome. So many people think about Rome in terms of the city of Rome, but in terms of the Roman Empire lasted until about the year 1450, because the Eastern Roman Empire, Constantinople, was Rome. That was the extension of the Roman Empire. And when Rome fell, many of the people fled with it, and they fled with manuscripts. And Cosimo Medici was one of the world's most brilliant bankers of all time, and he loved the classics. And he invested a great deal of his wealth in buying these manuscripts and wanted to establish a new academy. And he established Marsilio Ficino as the head of that academy, and charged him with translating these works. And another person that's worth mentioning is Aldus Manutius. I don't know how to pronounce his name, but the Aldine Press was based in Venice, and he was both a businessman and classicist, and he was sort of the same class as Lorenzo Medici, and he was the one who set to print all of this material. And this just had such an incredible effect on Western culture, because Plato, for instance, had been lost to the West for almost 1,000 years. And the rediscovery of Plato and other philosophical works like of Plotinus and Iamblichus and the works of Hermes Trismegistus and other classics like this really had a massive effect on culture. So Marsilio Ficino was a really interesting person, translator, and also a philosopher. And I was really delighted in the past couple of years when I came across a book of his that had not yet been translated out of the Latin. And so I've been working on this translation with Alice Ahern of Oxford University. And we've now completed his book, and it's a book on pleasure. And I think it's been really a pleasure to work on this. And so here's a quote that helps connect pleasure and harmony and beauty together. So he says, "Order is most greatly a property of reason. Therefore, in ordered compositions of sounds or shapes, there seems to be the traces of reason. Images of reason in songs or in numbered rhythms is harmony. In the agreement or fittingness of parts of a whole or limbs of a body, Platonists call beauty. These are not only alluring to the eyes and the ears, but they move the mind by the traces of reason they contain. And since they have natural kinship with the mind, they occupy the mind completely and seize it and fill it with a kind of ineffable pleasure of the soul." And so what he seems to be saying here is that there's a sort of resonance between the harmonious proportions or the beautiful proportions that we observe in the world and the mind, that we can somehow see or experience the reason, not through our reason, but through this ineffable pleasure of the soul. And that's something that can be unpacked further. But I hope that if any of you are interested, I'd love to share this translation with you, because it's a great story. There's a very nice arc to the book. So what this shows or illustrates is that harmony isn't just something that we can observe in the stars or observe in brain waves or observe in musical vibrations. It's something that we feel, and it's hard to explain with words. Even though I've been putting a lot of words to this and talking a lot, I found it very difficult to talk about harmony. There's something about it that makes it very difficult to talk about directly. It's difficult to talk about resonance directly. It somehow sits at this intersection of science and spirituality, and words can never do it justice somehow, but I think it's worthwhile to try. Now, there's a really important point that Aristotle makes about harmony and unity, and he calls it the error of Socrates. So he says this is a point at which a state becomes an inferior state, like harmony passing into unison or rhythm which has been reduced to a single beat. And what's important here is part of this wisdom that we get from music. Just listening to unison singing or a sine tone is not, in fact, the most beautiful music we can listen to. Harmony is better than unison. When we have diverse voices, when we have a kind of richness and variation that we can still bring into a whole, but where whole is different from unity. We want to have whole nations and whole economies and a whole world and wholeness with nature, et cetera, et cetera. But that is different from unity. It's different from uniformity or sameness. And so the notion that there is knowledge that we can learn from music about harmony as this integration of diverse elements into a whole has really been the point that I want to make. And here's a quote from Heraclitus that was contemporary with Pythagoras. He says, "There's a harmony in tension, as in the case of the bow and the lyre. Out of discord comes the fairest harmony." And this is represented in another contemporary philosopher, Frank Zappa. He says, "Music without dissonance is like watching a movie with only good guys in it, or eating cottage cheese." Well said. So the key takeaways here is that harmony is not unity or uniformity or sameness, but wholeness, and that it's something that we can understand, that it's difficult to understand, but there's a tradition of trying to understand it. And I think we should. And that from a fairly astonishing array of data, we do appear to live in a rational and harmonious cosmos. Things happen according to rational mathematical laws. Math in some ways underlies what the universe is made of, even more so than material substance. And music, however we want to define it or experience it, offers a wisdom that you can't just put into words. And I think that's important for the field of philosophy. And that harmony, I think, offers hope for sustainable futures. There's a lot of doom and gloom out there, and there's a lot of good reason for doom and gloom. But seeing how well we've been able to build 1,000-year-old societies, 2,000-year-old societies, I think we can make a go for another few thousand years at least. And I think that there's a possibility that understanding harmony more deeply could enable us to make that more sustainable future. There are many more things to say about harmony and sustainability. I'll leave with just a couple. One is that there's an interconnection between individual well-being and the well-being of the natural world. And that, in fact, if we shift our focus from happiness, which really has its conception around the individual, to one of harmony, there's a benefit because it reflects this interconnection. And what's interesting is that when researchers did this large-scale study of laypersons' conception of happiness, they interviewed, over 3,700 people in, I think, 14 different countries around the world. And they asked a series of open-ended questions about how people thought about happiness. They found that inner harmony and harmony with other people was the most common theme to emerge in all these different societies. And I think that's pretty incredible. Here's an example from the Netherlands of harmony in design with nature, or the harmony of the natural and the artificial. Because much of the Netherlands is below sea level. And much of the Netherlands would not exist without artificial interventions. So a series of dikes and polders and all those windmills, they're not for grinding grain, they're for pumping the water out of the land, out of the farmland. And one of the largest projects was undertaken in the 1950s, and that was to produce the newest province of the Netherlands. They blocked off the Waddenzee, and then they blocked it off again. And the problem is that when you block a sea off from the ocean and you don't have rivers kind of feeding it, and everything dies. And that's what happened. So everything in this sea died. The water became turbid and cloudy, and no longer the sunlight wasn't able to reach the bottom anymore, and all the plants died, and then the fish died, and the birds went someplace else. And so the Dutch approach to this has been to build these islands. And this is a great contrast to the Palm Islands in Dubai, islands that were artificial islands made for human pleasure. These are islands, artificial islands built to support nature. Now, it's been working so far. It's there's been a return of fishes in this area and birds, and it's also it's a nice place to visit, et cetera, et cetera. How well this will work and how much larger it has to be in scale is still in question. But I think it points in any case to the kind of dilemma that we're facing, where we have disrupted so many natural systems that while we want to preserve intact ecosystems to the best of our ability, we may have to make more interventions than we might feel comfortable to at the present moment. We may have to replant oyster reefs. We may have to get involved in creating biodiversity where it's been diminished. We may have to make artificial interventions in nature to expand nature. This is questionable. This is controversial. This is a picture of an artificial wetland on an artificial island in an artificial sea in a country that's famous for existing because it's under sea level. So what that means about the future of humanity, I think, is a good question. There are a lot of other things to say about harmony and sustainability, and for that you should buy the book. And it's not my book; it's this book. I cannot believe it. I was Googling this book when I was writing my book. I thought, oh, someone else must have written about harmony before. Let me look it up in Amazon, what's been written about this. And this came up, and this is when I discovered that there's another side to Prince Charles besides what you see in the tabloids. This is really an incredible book about esoteric philosophy and sustainable design. And it has everything from community-led methods for understanding needs and responding to them in towns that have lost their means of economic sustenance, to mechanisms for rebuilding diversity in mangrove farms, to how we can use the Platonic forms to generate new urban design concepts. I don't know what to make of it, to be honest, but I think it's really incredible that these concepts are being promoted by someone who's likely to be the King of England someday. And this also fits into my analogy of harmony, why it's so unpopular and why it might be popular in the future. And the analogy is mom jeans. Well, this may not resonate with you. The Netherlands is maybe the place to see it, but these high-cut jeans that were just the laughing stock of mothers for so long are now just the most popular thing. You wouldn't believe it, on all these girls with these high-cut mom jeans. Well, I think that these concepts are so normcore, in a sense. They've fallen out of favor, but they're so far out of favor that I think there's a good chance that they can come back in popularity and make an influence. So that's my hope in any case, is to at least lay out some of the possibilities and to show that even though it's a little bit irrational to believe that we live in a harmonious cosmos, it fits the data pretty well. And there's still quite a lot that we can draw from it, at least as inspiration for thinking about how to make a more harmonious future. And to note that a harmonious future does not necessarily mean that we're all agreeing with each other all the time. In fact, what that's likely to mean is that there's quite a bit of tension and conflict, but that we're able to leverage that conflict and tension to produce a greater whole. So with that, I'll take questions and see if we can't strike up a conversation.
Well, thank you very much. Let me see. Can you hear me?
Yeah.
Yes. Okay. Thank you very much, Derek. That was a rather interesting and broad coverage of many things. I'd like to ask a question to open up the presentation session here. I'm just wondering about if you might comment a little bit about harmony in the sort of Eastern religion or Eastern philosophy context. I know that you spoke about it in the yin and yang context, but I wonder if there's another bigger story about harmony in Eastern culture.
Okay, that's great. So have you read Hitchhiker's Guide to the Galaxy?
Yes.
Okay, so this is chapter 42 of the Tao Te Ching, the book on virtue by Lao Tzu. So if you've ever wondered what the question was, it might be this, which chapter?
Yes.
So this is chapter 42, and it goes, the Tao creates the one creates the two creates the three creates all things have yin and yang, producing the flow of energy for harmonization. So this is the Taoist perspective, and there's quite a lot more that can be said, and I've got some nice coverage of this in the article. I've got a conference that I'm attending, or a workshop in any case, with some Chinese scholars about the notion of harmony, because harmony is actually enshrined in the Chinese constitution as the objective of the government. So the objective of the government is to create a harmonious society. And it's been argued that harmony is the most cherished ideal in Chinese society. And it's something that intersects with conceptions of mental health, this sort of hierarchical approach of harmony in the self as the mechanism for producing harmony with others, and harmony in the state, and harmony in the natural world. There's this wonderful tension between Confucius and Lao Tzu, because Lao Tzu is very much about allowing natural harmonies to emerge. So action through inaction is quite a capitalist conception, I think, of harmony in a sense, that there are these natural resonances in the world that can emerge when we don't interfere too much. And so how to make sense of that, great question, but hopefully that gives a short perspective on harmony in the Eastern.
Okay, I also would like to point out that there's been some interesting discussion in the chat. So if you'd like to scan that at some point, and there's a couple of our participants that are they can listen in, but they can't actually interact with us easily. So one of them is Martin Brooks, and I think if Martin, if you can change your situation, you can always turn your camera on or your voice, but I'll speak to your question or your comment. Martin raised a point when we were back in the discussion about, let me find it, about the tempering of things. He makes the point of calling something called Stria, S-T-R-I-A. He says, check it out, by John Chowing, C-H-O-W-N-I-N-G. And Martin is suggesting that this is an alternative harmony based on artificial overtone physics, utilizing the golden ratio. So a bit of the math behind some of the things we were talking about before. So that's one thing. And the other is Gord Runts. I don't know whether he's been able to activate his system, but he's been listening. He's also, he's a musician, as in classical pianist is one of his great grand skills. And he just has a clarification on the issue of temperament. But I don't know whether he can communicate that to us. He just has this as a comment in the. So Gord, can you add anything here to this point you raised? You can type in the chat if you wish. Okay, well, while Gord does that, I'd like to open the floor to others. I see we have several hands up. So to start with, I'll turn it to Guy Stanley, and then that'll be followed by Gordon Dunstad. Go ahead, Guy. You're on mute.
There we go. Is that any better?
Yes.
Okay, well, I thought that was extremely, extremely worthwhile. An excellent presentation, and really worth considering. You raised so many interesting points, just largely because of a professional deformation on my part. I'd sort of like to drill down on one area of the talk, which is where you were discussing the early Enlightenment response, excuse me, to the concept of harmony. And you mentioned Newton and the responses to that. And it's true, people did use the vocabulary of harmony. But it's interesting, I think, that others writing on that at that time saw the most interesting part of Newton as the interacting counter forces that seem to keep everything in place. And they talked more about equilibrium than they did about harmony, hence the US Constitution, for example, and its division of powers. And I agree with you that if that's what you were implying, that this was a shift in meaning that was probably disastrous in the longer run, and that harmony is a much richer concept than equilibrium. And we need to get back to it. And I think that's one reason some of the wilder fringe of the hard right, for example, attacks the Enlightenment, says we need to go back before the Enlightenment in order to straighten out some of the kinks in the existing system. So, you know, the Enlightenment being a kind of an attack on the great chain of being, which might explain the Prince's interest in restoring that to our consciousness. Anyway, those are my immediately.
I love that. I love that. And I'll say e pluribus unum is, you know, that's the US motto. And that's what Cicero says that Pythagoras believed friendships should be.
Yes.
So out of many one. And so that's the US motto. The motto of the European Union is in Concordia, variety, and diversity and unity. And Indonesia also has a motto that is based on diversity and unity. Leibniz was a major proponent of the concept of harmony as diversity and unity. The idea of equilibrium versus harmony, I do think is important. Equilibrium, balance,
Right.
harmony. So the challenge with equilibrium is that, well, the best way to achieve that is just to blow everything up. And then you'll have death is a great way to achieve equilibrium. And, you know, while there's something to that, I think that the notion of this dynamic equilibrium is harder to understand both in the physics. I mean, how we get emergent effects is, you know, it's not that we understand completely, but dynamic equilibriums are so much more interesting. And so one of the big topics these days in the neurosciences is free energy reduction. I'm not sure if you've run across this, but there's this fellow, Carl Friston, that's promoting this a lot, that all these different systems can be understood in terms of their ability to reduce free energy. And that's similar in a sense to just the progression of entropy that, you know, in all physical systems, entropy increases. Even in open systems where entropy doesn't necessarily increase, free energy tends to be reduced. And while this goes a little bit off the rails here, I'm just going to point out that in the first, the earliest neural networks that were produced, they're sometimes called restricted Boltzmann machines. Jeff Hinton had a restricted Boltzmann machine, and what it would do was minimize free energy. But the first restricted Boltzmann machine was called the Harmonium, and that was by Paul Smolensky, and it maximized harmony as its metric. And they realized that it's just exactly the same thing, this minimization of free energy and maximization of harmony. So when they wrote a paper together, they had to pick a term, and they called it goodness of fit. And so all these deep learning neural networks, they still optimize for harmony by another name. So, you know, whether that's really harmony, because I'm kind of skeptical that you can put it all into a metric. But I think that story is interesting.
Okay,
Quite interesting.
anything else you wanted to say there, Guy?
No, I thank him for the for his answer on this. I think that, so I would say, misunderstanding in economics about equilibrium versus harmony is probably quite an important threshold to deal with.
If you like the economics piece, definitely check out the part of the paper about it, because there is, I think, a good moral justification for capitalism, which I think is extremely important in liberal society, because liberals can be quite lazy about dealing with capitalism and its benefits. Its critiques are sometimes much more apparent. And so why it's good is often, I think, lazily ignored. And the moral justification for capitalism has often been its ability to create these natural harmonies. I review the works of Bastiat, who
Yeah, I saw that.
Yeah, and then another one is Henry Charles Carey, who was Abraham Lincoln's.
Yes, I saw that too.
Yeah, okay, great.
Yeah.
Yeah, this was all totally, I had no idea about any of this stuff. And I don't know, you know, what economists think about it, but I do like the tension that harmony has around both capitalism and communism, because again, the Pythagoreans were the first communists, and harmony is the main moral justification for capitalism.
Well, it depends what you think cosmos is all about, it seems to me, but you're the expert there. How much, seems to me a certain amount of human intervention is necessary before harmony is sort of life supporting. And that's really where the debate is, and why people go for equilibrium, but they don't mean equilibrium as an end state exactly, so, which is often, I mean, I think that's, you know, your work for public policy, in other words, is pretty important. These are really critical nuances in the way we think about things.
Nice.
So thank you.
Okay, so Gordon is next, and after Gordon, I'd like to ask Stephen Panjoy.
Okay.
That will then Sydney after Stephen.
I have,
Go ahead, Gordon.
yeah, I have two comments. The first one is a bit of a Debbie Downer. It's just a warning. The second one, I think you'll find much more fun. The first comment is that the Pythagoreans told a lot of stories about Pythagoras, but the ones we can check are almost all false. Certainly Pythagoras did not discover the harmonic ratios. The chimes with disc-shaped chimes were already, harmonic disc-shaped chimes were already in use in the area around Croton before Pythagoras was there, or very shortly after he arrived.
I'm not familiar with that one. I mean, I know most of there's a reason why I describe this as the legend of Pythagoras.
Yeah.
And I think the legend is more truthful than the positivist conception, if I should say, because I think the legend is more real in a sense. There's a reason why it became so legendary. He obviously didn't discover the harmonic ratios. They were in use in Babylonia for at least 1,000 years before. But his ability to be attributed to them is real. I mean, his reception history, everyone wanted to attribute it to Pythagoras. So why is still, I think, a very unanswered question by the skeptics. And there's some great skepticism of Pythagoras, don't get me wrong. But I don't know this story, and I'd love to know it about the bronze chimes. If you knew
Archaeologists have discovered bronze chimes around that area from during Pythagoras' own lifetime. So it couldn't have come from him. And it's easy to recognize them because if you make a disc chime, and everything else is uniform between the chimes except the thickness, then the ratio of notes is inversely proportional to the thickness. So we can tell that they were harmonic chimes. So
if you could dig that up for me, I would really appreciate that, because I have really tried to find that. I've been trying to find any representation of archaeological. I mean, I should be looking for croton. One thing that's interesting is that Pythagoras probably influenced the coinage in Croton, because he was a cellator. His father was a gem engraver, et cetera, and the quality of the Croton coinage was phenomenal. I mean, there were these really beautiful coins, and they all date to right around his time. So I love the ambiguity of Pythagoras. Like, again, since he didn't write anything down, it all is still compatible with modern science. And even though that has to sit in a legendary space, I think we should just grab it, because it's, there's a lot to be disenchanted by, but yes, I do. I'm very aware that we're dealing with legendary material.
It's not that unusual among the early Greek philosophers for them to have started cults around themselves. I mean, a few of them did. It really was pushing back to the Hindu holy man type of thing, right? At that time, there was no real distinction between holy man and philosopher. So Pythagoras is interesting because he attributed things to math, which is really, that's why he was so useful to so many people.
And to women.
Later on, yeah. Okay, so that's the Debbie Downer part of my comments. I wanted to just harmonize with what you were saying, because I've been thinking recently about the fact that people tend to want to use physics models. So they tend to think in terms of cause and effect. But when you have a system made out of active agents like neurons, you can't really talk about cause and effect anymore. You have to start talking about feedback loops and so on. It's a much more complicated thing. And simple cause and effect doesn't really work anymore. And I think that applies to psychology. It applies to ethics, probably applies to economics. And certainly, well, it applies to ecology, and nowadays economics is considered to be human ecology. So we're getting into areas of study now where we can't use a simple physics model of cause and effect, where we have to start looking at feedback loops. And that's much more appropriate to talk about harmony in that context than it is to talk about cause and effect.
Interesting.
So that's just a thought. I've been thinking about this lately, but I don't have anything solid.
Yeah, I'd love, because you've obviously looked at this harmony paper. I'd love to share this resonance paper, because resonance is definitely an area where the challenge of understanding cause and effect, the circular causality, is really front and center.
Okay, good. I'll put a comment in with my email address so you can.
I'd love to share that.
Yeah, good. Okay, thanks.
Okay, thanks, Gordon. Stephen, to you, and after Stephen, Sydney.
Thank you. So that was really interesting. So I'll admit right off the top that I bring no particular prior knowledge of this other than I love music. But a number of things occurred to me, some of which you didn't quite get to. Maybe it's in your paper, maybe you have some thoughts. The first one was, to what degree are the maths around harmony fully known, or is that a growing field of research, and perhaps one suited to various forms of machine learning and AI?
I love that question, because it really drove me insane to get to the bottom of it. And it wasn't until this paper came out that I'll share with you here. And there were some others, but I was, so let me show one other one's. Let's see. Let me see if I can find this one. Yeah, okay, here's another one. Okay, so because right, this is the first scientific experiment of all time. So where are we with the science of this? And the answer is not that far. So Penelope Gook has this incredible book on the influence of music in the scientific revolution, and specifically the formation of the Royal Society. It's a beautiful book. It's really an incredible book. So many of the early experiments of the Royal Society were about music and about harmony. And I think that's instructive, but that is not the case today. I mean, music and science are very far apart from each other. And this paper that I shared, The Science of Harmony, is, I think, a recent breakthrough in understanding how harmonic relationships manifest differently in chords versus in melodies. And it gives a good overview, et cetera, et cetera. It's got a new model. It needs more validation, but it's pretty good. This other one, this archive article, is a neural periodicity model, because periodicity models, like that's the kind of kissing of the waveforms. They work really well, except they don't make any sense at all, because you'd have to pluck the string at exactly the right time, or else the waves would never correspond with each other. So the argument that's made in this paper is that our brain has these abilities to treat it as a period where it can sort of align the. Let me just back up one second. Our cochleas are in our ears are able to transduce sound waves into neural frequencies, and then the frequencies are preserved. So there's this volley model. So even though an individual neuron can only fire at about 200 hertz, our ears can transduce sounds up to, thousands and thousands of hertz right into the cortex. And so we've got this direct perception of musical frequencies. And so the musical properties of consonance and dissonance, from a physical perspective, surely in some way take place with these neural waves, but we don't understand that yet. We're getting papers out every year that's advancing this a little bit further. This guy, Gavin Beetelman, identified that we're able to observe this phase locking of neurons to the frequencies of sound all the way in the cortex. That was just 2 years ago. And then there's this other fellow, Andrew Ox, I forget his last name. I'm sorry about that. But he's done a series of studies showing that there's this one tribe in the Amazonia rainforest that doesn't recognize harmony or consonance and dissonance. So they could really care less whether they're hearing a chord that's dissonant or consonant. They like them all the same. Doesn't matter to them. You know, whereas we'd hear it and be like, "Ugh, like it sounds so horrible. We can't stand it." And they don't care. But he showed that they still have the perceptual fusion effects of consonance and dissonance. So the main theory of consonance is that those sounds blend into a whole well. And we like that. So he showed that this one tribe, like, they don't care, like, it's not that they like it anymore, but they still have that perceptual fusion effect where the sounds blend well and they can't identify that they're different sounds. So that's just to give a taste that there's still a lot of scientific progress being made. And I think we're still very far away from really having it figured out.
That segues to my next question. You kind of touched on it a bit, but most of your presentation avoided talking a lot about biology or biosphere or ecosystems, which would seem to me to be a goldmine of evidence of harmony that is in many ways more complex than, for example, planetary movement and that sort of thing. Is that a field that you're looking into?
Yeah, so Richard Dawkins, whom I'm sure we all admire, has stated in a recent paper that he considers the harmony of organisms in an ecosystem to be Dottie mysticism. Okay, Dawkins, whatever. So that's just to give
Dawkins is his own dottiness.
Right.
So he cares about at the gene level, whereas at the system level, it can have a different aesthetic. And
so in any case, that's just to give a foil. I think that there's so much recognition of the role of harmony in ecosystems and the way that those dynamic equilibriums can be formed. I think that one of the big questions is these Pythagorean ratios. Do they have anything to offer? Like, is there any connection between interlocking oscillations and ecosystems? I mean, anything? Well, you could look at, say, the periodicity of the cicadas, you know, the 13-year and 17-year cycle of cicadas. Well, they're clearly trying to avoid, by choosing those prime numbers, by evolving to those prime numbers, they're avoiding intersecting with the oscillations of predators.
mm-hmm.
Be very difficult to be a predator, and because there are lots of oscillations, predator-prey oscillations, like that, they oscillate all the time. So, okay, there's some.
So I guess I was thinking of biological or ecosystem harmony more from, inspired by the Confucian quote that you gave, where it's not necessarily about the maths of musical harmony, but more about the diversity and the integration of the diversity into more complex wholes and how that all works together. Which kind of segues also to my final question, which relates curiously to your Dawkins mention, because do you have any thoughts in sort of the history of Western civilization, if we're saying it starts with, the ancients in Greece and went through this period, which if DeSantis and the like are still representative of it, there's this tension between monotheistic influence in Western civilization and this form of inquiry and understanding of the world. So, for example, you used choral hymns earlier, and obviously there's tremendous music that has been a part of the religious tradition in the West. But the religious tradition in the West is very much one of appropriating things that pre-existing it and using it for its own ends while imposing its own epistemological kind of framework around it.
Yeah, much more of a focus on unity than harmony, I'd argue. So I want to point out this link. So let me just share this real quick, because when I was preparing this lecture for the Rittman, for a time I was thinking that I would do it using this tool Miro and give a history of human harmony, as it were, from the extinction of the Neanderthals to the discovery. So these are the first bone flutes that have been discovered in a cave that was not far from these two sculptures, which I'd love to say more about. But if we go from there into the kind of progression of civilization, where, for instance, we've got Göbekli Tepe producing these incredible sculptures and religious conglomerations, prior to the ending of the land bridge to the Americas, and the founding of some of the earliest cities, like that this city lasted for 5,000 years. And whatever kind of rituals were associated with these cities. So in the classical tradition in China, which, pointing out that you get cymbals and bone flutes at a very early stage in China, but that Confucius claimed that the rituals of music were part of what helped keep civilization together. I'm not entirely sure where I want to go with this, but if I were to just reflect back on the kind of Christian domination of all the different mystery cults and polytheistic belief systems, et cetera, and this ending state of the diversity and saying, oh no, we're only going to have this one belief system. And then you have the civilization collapse that, lasts for quite some time until we're able to develop some other mental model for dealing with Christianity and rationalism. And that rationalism actually allowed for this much greater diversity of thought, Spinoza and all the rest, enabling this diversity of rationalism. But now I think the challenge is, how do we allow for diversity of irrationalism in a society that still holds together? Because all these, whether it's music or ritual or weird belief systems or whatever else, they're not rational, but they can still hold society together. And we don't have any of those anymore. And if we're just trying to hold society together with the rational piece, well, then we need everybody to be rational. And that's a pretty, tall order. And so that we might try to promote more. I think about the way that festivals work in the Netherlands. Where everyone gets together, does a bunch of drugs and listens to music. And it's a communal experience that is part of society. And I think we need things like that. I think we can't only rely on the rational to hold society together. But so I don't know if that addresses but I wanted to show you the timeline. Did that come? Close. I love timelines too.
I'll let the floor move. Thanks.